All right, we're going to take a look at how to use Gaussian elimination to solve systems of equations. And we're going to start out with a 2 by 2, meaning a system with two equations with two variables or two unknowns. And we start out by writing a matrix, and we start out using our coefficient matrix, which the coefficients are 1, 1, 3, and -2. Those are just the numbers that are right here in front of your variables. Now, when we were doing inverse matrices, we would close this matrix off and then do some other stuff after that matrix. What we're going to be using is called an augmented matrix. For an augmented matrix, what we're going to do is put this vertical bar right here, and then we're going to put what the equations equal after that. So over here on the other side, you're going to have 3 and 4. All right, so this is just simply another way of writing the same equations right here, except without the variables. These are your coefficients, so this represents 1x plus 1y equals 3, and 3x minus 2y equals 4. Now, the first goal with your Gaussian elimination is we want to have a 1 in this top left corner of our matrix. The way these equations are written, we already have that achieved, so we do not have to do anything else to that. In some other problems, we'll get to the what happens if there's not a 1 right there already. Now, the next step is we need to get a 0 underneath that 1. So right there, that 3 needs to become a 0. And we can make that a 0 by multiplying. What we need to do really is we need to cancel this value out. A positive 3 will cancel with a negative 3. So what we're going to do is use this 1. We are going to multiply this 1 by -3, which will give this a -3, and then we will add it to this value right here. All right, so the top row is not going to change. That's going to stay 1, 1, and then 3. But now if we take row 1 and multiply it by -3, we are then going to add that to row 2. So let's see what happens. If you take this 1, multiply it by -3, that gives you -3, plus 3 is going to give us a 0 right here. Then we got to do that with each of these values here. So this 1 multiplied by -3 is -3. Added to a -2 will give us a -5 right here. And then this 3 multiplied by -3 is -9, and then added to the 4 gives us a -5. So once we have this situation where you have a 1 in the corner and then a 0 underneath it, we can write two equations out of this. Remember, this spot right here represents the coefficient for the y value. So this can be written as -5y equals -5, which means y is equal to 1. Now, this equation up here can be written as 1x plus 1y equals 3. And we know what the y value is, so we can put that in, giving us x plus 1 equals 3, therefore x is equal to 2. So your solution is a coordinate. X value goes first, and then your y value. All right, let's do the same thing, some Gaussian elimination, except we're going to use a 3 by 3, which means 3 equations with 3 variables this time. So the first matrix that we're going to write down is going to be our augmented matrix, starting with your coefficients of 1, -2, 1, 2, 1, -3, 4, -7, and 1. And then a vertical bar, and then our constants over here, 0, 5, and -1. So remember that our first goal is to have a positive 1 in this spot, the top left corner. We have that, so therefore we're okay. We don't have to do anything else to get that 1. Your next step is we need to get zeros underneath that 1. So right now what we have is a 2 right here. What cancels with a 2 is a -2. So what we are going to need to do is multiply this value by -2 and then add it to this value. That will cancel out and make a 0 right here. All right, so then the top row is not changing. The top row is going to stay exactly like it is. 1, -2, 1, and then 0. And so what we are doing to get a 0 in this spot is we are multiplying row 1 by -2, and then we are adding that to row 2. All right, so that gives us a 0 right here. Now -2 times -2 is +4, plus 1 gives us a 5 right here. Then we have 1 times -2, which is -2, plus -3 is -5. And then 0 times -2 is still 0, plus 5 is 5. Now we also need to get a 0 in this spot right here where the 4 is. So we're going to again use this 1 to get a 0 here. What cancels with a +4 is a -4. So we're going to multiply 1 times -4 and add that to this row. All right, so this is going to be -4 times row 1, and then we're adding those answers to row 3. That will give us a 0 right there. All right, so now we're going to take the next number. -2 times -4 is +8, and then +8 plus -7 is a 1. Then we move on to the next number. -4 times 1 is -4, -4 plus the 1, which is going to be -3. And then the 0 times -4 is still 0, plus -1 is negative 1. All right, so once we have this 1 here and zeros underneath it, once that has occurred, we are completely done with row 1. Row 1 will not change. We're not going to do anything else to it. So what I'm going to do is just rewrite row 1 down here. All right, so now our next step in this process, we got the 1, then we got the zeros underneath it. The next step is to get a 1 in this middle position. All right, so we need this number right here to be a 1. Well, one thing that we can do if we recognize all the numbers in this row are divisible by 5. So one of the things we can do is multiply row 2 by 1/5. We don't have to add it to anything. We just simply multiply row 2 by 1/5. Now when you take this 0 times 1/5, you still have a 0 right here. 5 times 1/5 is 1. Negative 5 times 1/5 is negative 1. And then 5 times 1/5 is 1. Now row 3, we didn't do anything with it. All right, so let's review the process. First step, we needed to get a 1 right here. That was already taken care of with the equations, so that was done. The next step was to use this 1 to get zeros underneath it. And so we did that by multiplying and then adding. Our third step is to get a 1 in this middle position. And we did that by multiplying 1/5 times everything in this row. And yes, multiplying by 1/5 is the same as dividing everything by 5, but we write it as a multiplication problem here. All right, so now after we get the 1, our next step is to get a 0 underneath it. Just like we used this 1 to create these zeros, we're going to use this 1 to create a 0 here. So what cancels with a negative 1? I mean, what cancels with a 1 is a negative 1. So what we need to do is multiply this value by negative 1 and then add it to this one. So what we are doing then is multiplying row 2 times negative 1, and then we are adding that to row 3. All right, so once again, the top row does not change. So 1, negative 2, let's see, 1 and 0. The next row is not going to change because we got a 1 in that middle spot where we wanted it. All right, so now when you multiply this value by negative 1 and add it to this value, you're going to get a 0 here. And this 0 does not change either. All right, so now the next one, we're going to multiply negative 1 times negative 1, which is positive 1, and then add that to this negative 3, which will give us negative 2. And then the last step We're going to multiply this times negative 1, which is negative 1, added to negative 1 is negative 2. Now remember that these just represent equations. So the next thing I can do is rewrite the bottom as an equation. The bottom row right here can be written as an equation. This is your coefficient on z, and this is the constant that it equals. So it means your equation would be negative 2z equals negative 2, and dividing gives us z is equal to 1. Now we can write an equation with this middle row. This represents your coefficient on the y, this is coefficient on z, and this is your constant. So this is 1y minus z equals positive 1. And since we know what z is, we can plug it in, giving us y minus 1 equals 1, so y is equal to 2. And then we can use our top row to write another equation, which would be 1x minus 2y plus z equals 0. And we know what z is, and we know what y is. So therefore that gives us x minus 2 times 2, so that's minus 4, plus the z value, which was 1, equals 0. We now have x minus 3 equals 0, so x is equal to 3, meaning our solution is now the x value, 3, the y value of 2, and then the z value of 1. And if you're not sure if these answers are correct, you can always substitute all three values back into each of our three equations to make sure that the left side does equal the right side of your equation.